Viewers, today we'll see about polynomials exercise 2b. Question 1. Verify that 3, minus 1 and 1 are the zeros of cubic polynomial p of x and verify the relationship between its zeros and coefficients. So it's given as cubic polynomial, meaning the degree, highest degree is 3. You can see it, x cube. So to verify the first condition, we have to do f of x, substituting the value of x as 3, minus 2 and 1 to see whether it satisfies the condition. So let's first take x as 3, f of 3 equal to 3 cube minus 2, 3 square, minus 5 into 3 plus 6. So 3 cube is 27. 2 cube, 2 into 9, 18, 15 plus 16, this is 0. So that's verified. Next we can verify for f of minus 2 by substituting value of x as minus 2. So minus 2 whole to the power of 3, minus 2 into minus 2 whole to the power of 2, minus 5 into minus 2 plus 6. That's going to be minus 8. 4 2s are 8 again, minus 8. Plus 10 plus 6, that's again going to be 0, minus 16 plus 16. Next we can substitute f of 1, that's value of x as 1. So 1 cube minus 2, 1 square, minus 5 into 1 plus 6. That's 1 minus 2 minus 5 plus 6. That's again 0. Next condition, we need to verify the relationship between its zeros and coefficients. So let's assume so we know that the equation for the cubic polynomial is ax cubed plus bx squared plus cx plus d equal to 0. So what are the sum and products condition over here? We can see, let's assume the value x as 3, y as minus 2, z as 1. It can be represented even as alpha, beta and gamma. So any just variable name. So x plus y plus z, that is one sum. Other sum is product of only two factors at a time. Sum of product of two factors. That's going to be of form c by a. And the product of all three, the x, y, z is equal to minus d by a. So we need to verify all these three are satisfied. So x plus y plus z is 3 plus minus 2 minus plus 1. That's going to be 2 by 1 minus b. So it's 2 minus 2. That's correct. Next, b value is minus 2 only here. Minus of plus 2. And a is 1, x cube. Next, we'll see the product of only two variables, x, y plus y, z. So that's minus 6 plus minus 2 plus 3. So that's going to be minus 8 plus 3, that's minus 5 by 1. So if you see the coefficient of x, that's minus 5, yes. Next, we see the product of zeros. So 3 into minus 2 is 6, minus 6 into 1, minus 6 by 1. So the constant is having the value of minus, that's plus 6. So it's verified for the given polynomial. Constant is plus 6 and a value is 1. Coefficient of x cube is a. Question 2. Verify that 5 minus 2 and 1 by 3 are the zeros of cubic polynomial and also verify the relationship between its zeros and coefficients. This is very similar to question 1. So we have to substitute the value of x as 5 minus 2 and 1 by 3 in the given cubic polynomial. So first let's do f of 5. 3 into 5 cube minus 10 into 5 square minus 27 into 5 plus 10. So that's going to be 5 cube is 3 into 125. 5 square 25 into 10 is 250. 135 plus 10. So this is going to be 0. Next, f of minus 2. So 3 into minus 2 whole cube minus 10 into minus 2 square minus 27 into minus 2 plus 10. So that's going to be 8 3s are minus 24. Negative sign remains minus 40 because 4 into 10, 40. Minus into minus become plus 54 plus 10. So minus 64 plus 64, that's 0. Next, f of 1 by 3. So 3 into 1 by 3 whole cube minus 10 into 1 by 2 whole square minus 27 into 1 by 3 plus 10. So one of the 3 goes off. It's going to be square. So 1 by 9 minus 10 by 9. 9 times 3 is 27. So that's going to be minus 9 plus 10. And it's like fraction. So 1 minus 10 is minus 9 by 9. So if you equate all, it's going to be 0. This is the first condition. Next, we can verify its zeros and coefficients. We know the relationship. Assuming x as 5, y as minus 2, and z as 1 by 3. X plus y plus z is of form minus b by a. So 5 minus 2, you need to take the LCM. 5 3s are 15, 2 3s are 6, 1. So that's going to be 10 by 3. So value is of form minus b by a. So value of b is minus 10. Yes, x square's coefficient is minus 10. X cube's coefficient is 3. Next, we can find xy plus yz plus zx. It should be your form c by a. Let's verify it. Minus 10 minus 2 by 3 plus 5 by 3. These are like fractions, so it's become 3 by 3 is 1. So that's going to be minus 9, which is of form c by a. But if you see, the value of c is not minus 9. So we need to make it equivalent fraction by multiplying with 3, both numerator and denominator. This becomes minus 3 into 3 is 27. And the denominator is just 3. 1 into 3 is 3. So now it satisfies the condition. 27, the coefficient of x, and 3, coefficient of a. Next product condition of 0 is xyz. That's going to be minus 10 by 3, which satisfies minus d of a. Minus into minus is 10 by 3. So the constant value is plus 10 and coefficient of a is, x cube is a. So this satisfies. Question 3. Find the cubic polynomial whose zeros are 2, minus 3 and 4. So the actual cubic polynomial is mapped in such a way x cube minus of sum of zeros, that is a plus b plus c, and sum and product of sum of ab plus bc plus ca is part of x, the coefficient of x, minus ab, c, that's the product of zeros. So with this we can compare to the given polynomial ax cube minus bx squared plus cx plus d. So the value of a is 2 minus 3 plus 4. So that's going to be 3x squared minus 6 B and C is minus 12. CA is 8 into X. Product is going to be 2 3s are 6, 6 4s are 24, and minus the minus of minus 24. So with this we can derive the polynomial x cube minus 3x square minus 10x plus 24. So this is the required cubic polynomial. Find the cubic polynomial whose zeros are half, 1 and minus 3. So very similar to the pattern or like a previous question. So we can just write x cube minus of sum of these three, 1 by 2 plus 1 minus 3, x square plus product of any two zeros. So it's AB 1 by 2 minus 3 minus 3 by 2 into x, and then the minus of product of all three zeros. So that's going to be minus 3 by 2, minus of minus 3 by 2. That's going to be the constant. So we can do the LCM here. 1 plus 2 minus 6 by 2 into x square plus, these two are like fractions, so that's going to be minus 1 minus 3 is minus 4. Minus into minus plus 3 by 2. So that's going to be x cube minus into minus is plus. That's going to be plus 3x square by 2 minus 4x plus 3 by 2. So we can multiply by 2 to all the terms. 2x cube plus 2 and 2 goes off in x square. So it's going to be 3x square. 4 into 2 is minus 8x. 3 and 2 and 2 goes off in constants. That's plus 3. So this is the required cubic polynomial. Question 5. Find the cubic polynomial. Its sum of its 0, sum of the product of its 0 taken 2 at a time, and product are given respectively. So sum is the one, x plus, we already know how it is mapped to the cubic polynomials. Sum is mapped to the x square. Sum, that's going to be 5. Sum of product of any two at a time, that is like xy plus yz plus zx, or ab plus by, bc plus ca, or whatever you are assuming, alpha beta plus beta, gamma plus gamma alpha. Here I'm taking only as ABC. Product is AB into C. So with this we can construct the cubic polynomial. 5 belongs to sum because respectively they are mentioned. So that is 5. And product of any two at a time, that is AB plus BC plus CA, is going to be minus 2. And product is ABC, that's minus 24. So the actual polynomial is x cube minus 5x square minus 2x minus of minus 24. So it's becoming plus 24. That's the constant value. Question 6. Find the quotient and remainder for the given f of x and g of x. So we need to divide it by actual division. Divisor is x square minus 2. So to make it as x cube, we need to add the quotient x. That's x cube minus 2x. So x square term is 0. Let's keep it as 0x square. This is actual division, so we can just subtract. X cube goes off. Minus 3x square. Minus 2x become plus. Minus into minus. So 5 plus 2 is 7x. Minus 3. Now if you just multiply by minus 3, this term is going to be minus 3x square. Minus 2 into minus 3 is plus 6. This is a constant term. So we just write it in the constant term as 6 and keep x term as 0x, as we do not have anything. Again, by subtracting, x square term goes off. So that's going to be 7x. Minus 6 it becomes. So minus 9. Minus 3 plus minus 6 is minus 9. So here the quotient is x minus 3 and the remainder is 7x minus 9. Next, question 7, again we need to do the get the quotient and remainder for the given polynomials. Here if you see x cube term is not there, so just keep it as 0x cube minus 3x square plus 4x plus 5, and the divisor is x square minus x plus 1. So just by adding x square to the quotient, this is also x to the power of 4, minus x into x squared is x cube, that is 1x square. So it's actual division, so subtract x to the power of 4 goes off, x cube minus 4x square plus 4x. So just by adding plus x, we get it x cube minus into plus. So that's minus x square plus x. That's again 1x. By subtracting, x cube goes off. This become plus. So minus 3x square. That becomes minus. So 4 minus 1x is 3x plus 5. So just by adding minus 3, we get minus 3x square. Minus into minus is plus 3x. Plus 1 minus 3 is minus 3. Subtracting, x square term goes off. This x term also goes off. And constant minus 3 become plus 3. So 5 plus 3 is 8. So here the quotient is x square plus x minus 3 and the remainder is 8. Next, question 8, find the quotient and remainder for the given polynomials. Again, we need to do the actual division. X to the power of 4, x cube is not there, x square is also not there, minus 5x plus 6, and the divisor is minus x square plus 2. Minus x square, it becomes x to the power of 4 minus 2x square. So there's no x cube value here. So it's going to become plus 2x square minus 5x. So just by putting minus 2, it becomes minus into minus plus 2x square. So quotient we need just add minus 2. 2x square minus 4 is the constant value, no value for x term. So we just substitute it as 0x. Now by again subtracting, x square term goes off. Minus 5x, minus into minus become plus 4. So 10 plus 10. So here the quotient is minus x square minus 2 and remainder is minus 5x plus 10. Next, question 9. By actual division, show that x squared minus 3 is a factor of the given polynomial. So we can just write the dividend first. All terms are available. Just by adding 2, multiplying by 2x squared, you get 2x to the power of 4 minus 6x squared. So there is no cubic term. We can keep it as 0x squared, x cube. By subtracting, x to the power of 4 term goes off. So it becomes 3x cube minus 6x squared become plus. So 6 minus 2 is plus 4x squared minus 9x minus 12. So just by adding plus 3x, you get 3x cube minus 3 into 3 is 9x. There is no x squared term. So that's going to become 0x squared. Again, by subtracting, x cube term goes off. 4x squared. Even minus 9 become plus 9. So now x term goes off. It's only minus 12. Now by adding 4, you get 4x squared minus 3 into plus 4, that's 12. So the remainder is 0. This proves, yes, it's a factor of the given polynomial, as the remainder is 0. Question 10. On dividing the polynomial by g of x, quotient is given and remainder is given. Find g of x. So the divisor is missing here, and we know as per Euclid lemma, dividend equal to divisor into quotient plus remainder. So dividend is 3x cube plus x squared plus 2x plus 5, and the remainder can be subtracted from this when it comes to left hand side. Divisor is g of x and quotient is 3x minus 5. So here x and constant term need to be simplified further. 3x cube plus x squared minus 7x minus 5. We can do the actual division now. 3x cube plus x squared minus 7x minus 5 divided by 3x minus 5. So just it becomes x squared. So 3x cube minus 5x squared. Subtracting it, x cube term goes off. Minus 5 become plus 5. So it's going to be 6x squared minus 7x. Minus 5. So just by adding plus 2x, it becomes 6x squared. Minus 5 into 2x is minus 10x. Subtracting, x squared term goes off. So we get minus 10 to the plus 10. So 10 minus 7 is 3x minus 5. Just by adding 1, we get the remainder is 0. So we got the g of x.